All right, welcome everybody to another live stream. In this live stream, what we're going to work on is the hyperbola in analytic geometry. So what I wanted to do in this one was a little bit different. So I went ahead and made a post and on my Facebook account to ask you guys to get in some questions. So I'm going to try to get the questions like I've done in my previous live streams, but I am going to start with the questions that were at least submitted before. And one of the things I wanted to change up, even though we are coming into the end of this lesson as well as to the end of the year, I am going to kind of work on at least keep making this consistent. So for those of you that are still going to be taking some more classes or need that live stream, need that math help for the next couple months, look out for some new announcements for me letting you know of my schedule. So therefore you guys can go ahead and submit questions and get help. And then also to go ahead and review a lot of the math work that I am going to be doing in the next couple weeks, because even though we'll be done with teaching, we'll be finishing up our school year in the next couple months, I am going to still be obviously going through some content and would also like to do some more live streams with you guys. So what we're going to do in this one is very similar to what I've done before. I'm going to go ahead and cover the hyperbola. We're going to look into determining the center, the foci, the vertices, and the asymptotes, and then sketching the hyperbola. And then so I'll kind of show my work, go through them. We'll look at how to write the equation of a hyperbola, not a parabola. So let's change that. How to write the equation of a hyperbola given some information. And then we'll go ahead and work on some multiple choice questions and kind of go from there. So I'll go ahead and take a break. If you do have any questions, make sure you guys set them up into the chat. And after I'm done with the first half, I will go ahead and kind of, adjust for any of those questions you guys have there. And then what we'll do is I'll just kind of open it up depending on the time constraints I have. I do have a couple questions that were submitted that I will try to work on first. And then I'll get to if there's any other open questions for when we have time. So I see Shayla. Hey, Shayla, how are you? Good to see you. Long-time student. Ellie and Rosie, Saeed, Nick, John Lee, good Megan, good to see you. See you guys all in on there. So very happy to Shalini, and Chandler. Good to have you guys on the live stream. So let's go ahead and get into this work. And then what I'll do is I'll kind of take a break midway through. So given the following questions, determine the center, the foci, the vertices, the asymptotes, then sketch a graph. Now, obviously, this is something that we've already covered in my class, so I'm not going to, for those of you anyone new on the live stream, I'm not going to go through introductory of this work. Basically, what I'm going to do is just kind of, quickly go over some of the formulas and definitions that we have. So the main thing, when looking into the hyperbola as far as how that compares to the ellipse, remember, I was looking at this subtraction sign, and our main thing we want to be able to identify is what is going to be our a squared. And for the hyperbola, we had the a squared was going to be that positive term. A lot of times it's just written first, like a squared minus the b squared. So a lot of times we can just go ahead and write this in there, but it's not always the largest, which was like the ellipse. So the ellipse was always the larger denominator, was your a squared. Well, in this case, it's always a squared is always going to be your positive term, typically written first. So in this case, let's see, did I do another one? Did I do all those? Jeez. I think I did the first one always be positive, at least for the homework assignment, but we changed that up in our classwork. So in this case, a squared is going to be 16, and b squared is going to be equal to 9. Therefore, a is equal to 4, and b is equal to 3. Now, the one thing also to remember, the relationship between a, b, and c is different for a hyperbola compared to an ellipse. So this is a squared plus b squared equals c squared. So therefore, you can see that c squared is going to equal 25. Now, the nice thing about about the hyperbola is the values of a, b, and c represent the same thing. A represents the distance from the center to the vertices, b represents the distance from the center to your co-vertices, and c represents the distance from your center to your foci. However, instead of like a major axis from vertice to vertice, we now call that the transverse axis. And instead of the minor axis being like from co-vertice to co-vertice, that we now call that the conjugate axis. So the next thing we want to do here is go ahead and identify the center. Well, again, the center is in your term that x minus h and the y minus k. So in this case, we can just see that the center is going to be 0, 0. Now, just like in an ellipse, when we have our a squared under the x squared, previously for an ellipse, that told us that the major axis was going to be horizontal. Well, in this case, that's going to tell us that our transverse axis is going to be horizontal. So the best thing I think to do for this is just to sketch the graph, just so you can kind of get like a visual of what's going on here. So we have the center here at 0, 0, and I'll put a nice little C here to represent that. Since my a squared again is under my x, that means my vertices are going to be going left and right from that center. So I'm just going to go left 4 units, 1, 2, 3, 4, and right 4 units. There's your vertice and your vertice. And therefore, the main thing is to understand on the transverse axis is that your vertices as well as your foci both lie on your transverse axis. And you can see that my foci is going to be 5 units away to the left and to the right. And remember, your hyperbola is going to be opening up from your vertices, is going to be opening up towards the foci. So it's just going to look, something like that. Something not really the best, but there you go. The next thing we want to be able to identify is the foci, the vertices, and the asymptotes. So the equation for the asymptote, when you have a horizontal major axis, I'm going to go ahead and write this in there. So the asymptotes for a horizontal major axis would be y equals plus or minus b over a times x minus h plus k. Now, since our h and our k are both 0 and 0, it's just going to be b over a. Well, remember, b in this case is 3, and a in our case is 4. So my asymptote equation is going to be y equals plus or minus, this will be 3 over 4 x. Now, we could go ahead and graph 3 over 4x. From here, you can see that obviously the two asymptotes are going to intersect at the center. Another kind of trick here is, I didn't actually go through this in my class, so for those students that are watching here, that we didn't really spend too much time really needing to worry about graphing the asymptotes. But if you kind of create a box with your covertices and your vertices, what you notice is that the asymptotes actually go through these corners, the corners of that little box. So just a nice little neat thing to represent. A lot of times people, if they have trouble graphing y equals plus or minus 3/4, there's where you can get those asymptotes as well, just kind of through that box there. All right, I forgot to actually write in the foci as well as the vertices. So the vertices are just going to be plus or minus 4, 0, and the foci is going to be plus or minus 5, 0. And there you go. So that's basically all we need to do in that standard form. Now, obviously, you can see that this one is at the origin. And the next example, you can see my x and my y's are being transformed, right? So that's where that x minus h, y minus k kind of format comes from. So you can see here that basically now my center has been shifted, right? Now remember, the h always goes with the x, and the k is always going to be related with the y. So in this case, just without writing anything, I can say that my center, and remember it's always opposite, is going to be -3, 1. Now the next thing I want to do is identify my a squared and my b squared. So again, since my a squared is first, this positive a squared minus the b squared. So in this case, I'm going to have a squared is equal to 4, b squared is equal to 1, and c squared is going to be a squared plus b squared, which would be 5. So let's write these out. A would be 2, b is 1, and c is equal to the square root of 5. And the reason why I'm not doing a plus or minus is because the definition of our a, b, and c was the distance. So it's an absolute distance, because you can notice that the vertices as well as the foci are going left and right. All right, now you can see that my a squared, though, is under the y, so that means now I'm going to have a vertical transverse axis. So as I go ahead and graph this, so -1, 2, 3, +1, now my vertices and my foci are going to be going up and down from the center rather than left and right like this last example. So I can see that my vertices here are going to be up 2 and down 2. So the nice thing is, I like to graph them just because, obviously you could do your math, like add 2 and subtract 2 from there. So when you add 2, then you're going to have, I'm sorry, not foci. so your vertices, is going to be negative 3, comma 3. And then the other vertice is going to be negative 3 minus 2, so that's going to be negative 1. And then, and now to go through our foci, which is going to be the square root of 5. Now, obviously, I don't have a calculator, and I don't want my students to be approximating anyways. So what I simply just recommend for my students is just to do plus or minus the square root of 5. Now, we could estimate that, and the square root of 5 is obviously going to be between 2 and 3, because the square root of 4 is 2, and the square root of 9 is 3. So it's going to be somewhere in between 2 and 3. So therefore, we can go in and still estimate that for on the graph. So let's go ahead and write this negative 3, comma 1, plus or minus the square root of 5. So again, that's going to be 2, between 2 and 3. So somewhere like around there. So 1, 2, 2, and 3. So that would be my foci. And somewhere there. So the foci is going to be rather close from there. But obviously now at least we can get the idea of my hyperbola, the way it's going to look. And then last thing we need to do is just do the equation. So if the horizontal parabola is y equals plus or minus b over a, for the vertical parabola, that's going to be y equals plus or minus a over b times x minus h plus k. So we already have the x minus h, which is x plus 3. We have our value a, which is 2, and our b, which is 1. So I'll just write this out. Y equals plus or minus 2 over 1 times x plus 3. Now we got to figure out the value of k, which is actually going to be positive 1 plus 1. So therefore the equation, which you could simplify, but I'm just going to leave it in this format, because I know where my asymptotes, remember these asymptotes though are going to go through the center. If you do need to graph them, that is going to be important. And obviously I'm not being very accurate with my graphs, but you could see if you were to graph these two equations, put them in slope-intercept form, you can go and graph them, and obviously you'd get right in there. But we have the vertices, the foci, and the asymptotes, as well as the center. And there you go. All right, so those two are in standard form, and they're really in a relatively the standard form that we, kind of looked at in our notes. The next two examples, well, this one is still in standard form, but it doesn't look like these first two problems. So the difference being is these two problems are set equal to 1, and the notes that we did in class, the equations were also equal to 1. Well, this one's equal to 100. So if I want to set this equation equal to 1, I need to then go ahead and divide by 100. So when I go ahead and divide by 100 here, distributive property of division here to make sure you divide both terms by 100. I'm going to have a y squared over 25 minus a x minus 5 squared over 5 equals 1. So now in this case, what you can see is now it's back into that form. So all I simply did is just divided by 100 on both sides, and you can see that where we got to that now. I think I wanted that to be, let me change, well, I mean, I guess I'll run with it, but I think I wanted that to be a 25. Let's go ahead and change that just to be a 25, just to make our math a little bit easier. Because, yeah, that's a little bit more typical, is at least to make that 25. So I'm going to make that executive change here. All right, so now we have that and problem. And basically the reason why I wanted to do that is because when you're taking the square root of your a squared and your b squared, I would have had two numbers with radicals, which is fine. But just to kind of keep things, just to make the math a little bit easier as far as doing the work, just having one radical is okay. We'll just keep with the one radical. So in this case, again, it's not because 25 is larger, it's because 25 is labeled first and positive. So in this case, my a squared is 25, my b squared is equal to 4, and my c squared is equal to the sum of those two, which would be 29. So therefore, a is going to be equal to 5, b is equal to 2, and c is equal to the square root of 29. We can see that the center, I'm going to just move this a little bit quicker. The center is going to be 5, 0. Let's just go ahead and sketch this real quick. That's going to be 5 units to the right. 1, 2, 3, 4, 2, 3, 4, 5. All right, notice that my a squared's under the y, so it's going to be just like the last problem we did here. So we're going to have a vertical major axis. Therefore, my vertices are going to be up and down from the center. Well, 5 units. Well, that's not going to be too bad. I can just go up and down 5 units from there. So it'll be 5, 5, and 5, -5. And then my foci, I don't know why I put a dot over the C, is going to be up or down a square root of 29. So I'll write that as 5, plus or minus square root of 29. And then we just need to remember the asymptote equation for a vertical transverse axis, which I'll just kind of draw that vertical transverse axis. Therefore, I'm going to have A over B. So that's going to be y is equal to plus or minus 5 halves times x. We already have the x minus 8, so that's going to be x minus 5, and then plus 0. Your k is 0, so that makes life kind of easy there. So that's our equation of our asymptote. You could obviously distribute that if you wanted to, but we'll just leave it from there. All right, so the last example is in general form, which means we have to go ahead and complete the square in this example. So since all of my equations here have the x's and the y's on the same side, that's exactly what I'm going to want to do. I'm just going to want to keep everything, but you notice that when we are identifying the center of your hyperbola, we have them in terms of what we call a binomial squared. So that's exactly what we want to create here, is create a binomial squared. So what I'm going to first do is just going to organize the x's and the y terms together. So I have a 4x squared minus 4x minus a y squared, and then actually this 3, oh shoot, now I'm trying to wonder what I would have done with that y squared, because obviously I did not copy down this problem correctly. So shoot. So obviously, no, I guess I could. Yeah, let's go and work with it from there. I'm not actually sure. I don't remember work the problem. So let's keep it as this 3. What I'm actually going to do is I'm going to keep the 3 to the other side. All right, so there's really nothing I can do with this y squared here. So therefore, the only thing I can really complete the square with, or create a perfect square trinomial, is with this x. So what I'm going to do, first thing I'm going to do is factor out the 4. So I have a 4x squared minus x, and then I'm just going to rewrite this as a minus ay squared equals 3. This is not going to be a fun problem, but I'll go ahead and do it. I think I wrote down the problem wrong, but either way, let's just go ahead and work through this one. So 4 times x squared minus x. To go ahead and complete the square, remember that's going to be b divided by 2 and square it. So in this case, I'm going to have negative 1 divided by 2 squared, which equals a 1/4. So I have 4 times x squared minus x, and then we're going to add a 1/4. But remember, you can only add a 1. If you add a 1/4 on the left side, then you're going to have to add a 1/4 to the right side. So I'm going to add a 1/4 to the right side. But now be careful. You didn't really add a 1/4 to the left side. You added a 1/4 that's being multiplied by 4. So this one is going to be added by 4. So now, when I go ahead and factor this down, now some of you might get confused and say, well, how are you going to know when to factor that down? Or, how can you factor that binomial? Well, by completing the square, you're always creating a perfect square trinomial, meaning this can always be factored down into a binomial squared. So the other term that I mentioned with our students is, it's either going to be plus or minus b over 2 squared. Well, my b divided by 2 was negative 1/2, right? So this turns out to be 4 times x minus 1/2 squared minus 1 squared. 4 times 1/4 is just 1, so that equals 4. So actually, this problem actually isn't too bad. Not as bad as I was originally looking. Now the problem is written like over here. So to get this to equal 1, I'm just going to divide by a 4. And therefore, I'm left with x minus 1/2 squared minus y squared over 4 equals 1. All right, so now finally I got to a problem where you can see that my y squared is under, my a squared is under x. It's not the largest though, right? So 4 is larger, but that for an ellipse, that would be your a squared. But again, for the hyperbola, your a squared is always going to be first, or at least the positive form. So in this case, my a squared is equal to 1, my b squared is equal to 4, and my c squared is going to equal to 5. Since my a squared is under the x, that means I'm going to have a horizontal transverse axis. My center, I'm going to do this in my head just to kind of like speed things up. My center is going to be at 1/2, comma 0, since y I'm not subtracting anything from. And then I'm going to be adding and subtracting everything left and right, which is not going to be very fun with the fractions, but that's okay. We can write our fractions with the common denominators here. So we're going to be moving left and right 1, as well as left and right square root of 5. So let's actually, I forgot to write those in there. Let's actually move that down. All right, so let's put this as a is equal to 1, b is equal to 2, and c is equal to the square root of 5. Okay, well, so the vertices are not going to be too bad because you're really just adding 1 and subtracting 1 to your x coordinate, right? So hopefully you can see that that's going to be negative 1/2, comma 0, as well as 1 plus 1/2 is just going to be 3/2, comma 0. We're running out of room though. My foci, I'm just going to use the radical, so I'm just going to have that as a positive 1/2 plus or minus the square root of 5, comma 0. And then my asymptotes, since it's a horizontal, that's going to be my b over my a. So that's going to be y equals b over a, so that's going to be 2 plus or minus, oops, I'm sorry, what am I doing? That's plus or minus 2 b over a, so that's 2 over 1, times x minus h, so that's going to be x minus 1/2, plus k, and k is 0 in this case. So therefore it's just going to be plus or minus 2 times x minus 1/2. So there you go. Just 2 more questions, guys, and then I'll go ahead and get into some of your guys' chat here and see you guys that are still on. Hopefully and then hopefully try to wrap this up and see if I got into any questions for you guys. So these next 2 shouldn't take too long. And basically what we're going to do is look into writing the equation. So given the following information, write the equation of the parabola. So in this case, we have the conjugate axis. Now, the conjugate axis, remember, connects the covertice to the covertice. So we know this is the distance of equal to 2b. All right. Now they give us the foci, and they give us 2 plotting points. So what I tell my students is plot the points. So let's plot -2, -2. That's 1 foci. 6, 1, 2, 3, 4, 5, 6, -2 foci. So automatically right here, we know that the transverse axis is horizontal. We also know that the center is going to be the midpoint between my 2 foci. We know the distance between the center and the foci is going to be 1, 2, 3, 4. So we could say C is equal to 4. From here, we know B is equal to 2. We know that it's a horizontal transverse axis. And we know that the center is going to be at 2, comma, -2. So just by plotting the information, we're given the center, we're given the value of C, and we're given the value of B. Now, the only thing we need to figure out is we need the center and we need A and B. So the last thing we need to do is just figure out what A squared, what A is going to be. So that's going to be A squared plus B squared equals C squared. So we don't know A squared, but we know B squared, which is 4, is equal to 16. So A squared is equal to 12. Now we don't need to solve for it. We're just good right there. Now remember, that's your H and that's your K. So remember, it's always the opposite, right? Since it's a horizontal transverse axis, my A squared is going to be under my X. So I'll write this as a X minus 2. squared over 12 minus my y plus 2, because the opposite of negative 2 squared, over my b squared, which is 4. All right. The next one is I'm given the asymptote, and then so the only thing is, remember, there's two different equations for your asymptote. You either have an asymptote for the vertical or you have an asymptote for the horizontal. But the nice thing is, if you have the equation of the asymptote, you know what B, A, H, and K is. So all you need to do is just figure out, is it a horizontal or is it a vertical transverse axis? Well, this one says it's a vertical transverse axis. So therefore, we know our equation. I guess I'll finally write it in here for the first time. Remember, is y minus k squared over a squared minus x minus h squared over b squared is equal to 1. So in this case, we have x minus h, which is 2, and then that's going to be our k, and then since it's vertical, that means that's going to be our a, and that's our b. So I can just simply plug this in here. So this would be y minus 1, because that's k, so be careful with that, all over a squared, which is 9, minus my x minus 2, that's already in the form that I want, squared, over b squared, which is 16, equals 1. So there you go, ladies and gentlemen. That is hopefully how you, that is how you're going to go ahead and write the equation, as well as, given the equation, go ahead and sketch a graph and go ahead and plot the parts, including the asymptotes, the foci, and the vertices. So now what I'll go ahead and do is I'll get on to the multiple choice. But before I go and do that, I do have a couple announcements for you guys that I would like to share for you. So, wow, a lot of you guys, do you have the sketch the fourth example on the front? You just finished. I'll get to that. So a couple things. So as I mentioned, one of the things that I'd like to do is right before we went on spring break, I kind of did like an open Q&A, and I wasn't really prepared for the open Q&A. It was just kind of one of those things. I'm like, let's do a live stream and kind of see what happens. And I got a lot of questions, and it was very hard to monitor the questions as well as kind of teach and do it. However, I really did like the opportunity, just to kind of like serve you guys and, go and chat and not really have an agenda and just kind of, go about doing math and problems you guys had. So one thing I'd like to do is continue doing that. And so as of right now, I'm going to plan on doing that on Mondays at 9 o'clock. And what I'll do is kind of like what I did for this live stream is I'll make a post on my Facebook account. And therefore you can go ahead and follow that free math videos, and then if you have questions, you can submit it. The reason why I like the Facebook over the YouTube is just so you can take a picture and send me stuff, which some students already did. So I like that idea. Obviously, guys, I am not a genius. I cannot solve every single type of question. It's been a while since I've taken a lot of the upper level mathematics courses or just other classes. I've taught calculus for a couple years, but this year I'm only taking pre-calculus. So there's going to be some questions I'm just, not going to be able to solve, or just not willing to go through that at length over a live stream. But please go ahead and submit, and either I will respond. I'll try to either give you a answer either on there if it's something quick and easy that I can do, or I'll try to go through a live stream, or unfortunately it's just the reality, guys. I'm not going to be able to get to everything, but hopefully that can at least bring up a conversation for that. And then for my classes, we only have really one more chapter left, so I'm going to kind of continue this as much as I can. If you guys haven't already noticed, there's a lot of boxes behind me. So the reason why it's kind of been a little bit difficult here is just because my family, we're actually in the process of moving, still within Jacksonville, so we're not going anywhere else, but we're in the process of moving. So it's a little bit crazy, hectic. I am hoping in the new house that I will have a little bit more room for a studio and something that I won't need to set up all the time, like what I have now. So, but that's kind of hoping some things that will be coming up. But unfortunately, in the next couple weeks, it's going to be kind of crazy because we're going to be having a lot of boxes and moving and stuff like that. So, but either way, we have one more kind of lesson where I'm going to be doing these, and then obviously I'd like to continue these open streams. So if you haven't already been a part of my page on Facebook, please make sure you go ahead and like it or be a part of it if that's something that is of interest to you. And then obviously if you are also a YouTube member or a part on my email, then obviously I'll also be letting you know of when I'm going to be going live, as well as when to submit questions. So in the second question, all right, so let's go ahead and take a look here. See the work. Your face cam was blocking it a little bit. Hey, I'm going to check the first problem in the second section. You didn't square 4, making squares 6 to fit the form. Which problem was that? A squared, C squared. Check the first problem in the second section. So C is 4. So C squared is 16. I'm not sure. Our second problem? Hey Liam, how are you doing? Sorry, I'm just go ahead and checking out some work before I go ahead and move on. Ivan says range is how tall the function is vertically and the domain is how function is horizontally. Yes, Ivan, that is one way you can think of it. It's kind of a simplified version as far as domain and range, Ivan. But yeah, that is not a bad, I say that a lot. It's a very simplified approach. It's not the best mathematical definition, but for a lot of problems that will definitely work. All right, Kitty Game, you're going to have to let me know. I'm seeing that I squared this, so I'm not sure if my question or what you were referring to gets down to it. I know you did ask, do you have to graph this? Obviously, as far as for my own students on a test or quiz, when I'm looking for a sketch of the graph, these graphs do not look that great. But that's something I'd be looking for, as far as students, just being able to have a general idea of the center, the vertices, and the foci. Fractions are fair game. So our radicals, just an estimate is going to be all I'm really asking for. And one thing to kind of let you know as far as like the asymptotes is, if you can create that box with your vertices and your co-vertices, that can help you go ahead and graph the asymptotes rather than trying to rewrite this in slope-intercept form and go ahead and graph them. But again, I'm not trying to be picky with you drawing your asymptotes or your graph. I really just want to make sure that you have the general idea of what the graph should look like. So not to be overly picky. So thanks for making your math a lot easier. You're very welcome. Snow, how did you get that? What is the period of the function? Kyle, all right, you're getting a question is squaring a period. I'll go ahead and try to circle back to those once I am done. Yes, Ivan is 2 pi for sine and cosine functions is 2 pi divided by b. That's for cosecant as well as for secant. I'll try to see if I can get to that in there as well. All right. So I think that was all the questions on there. I'll try to come back to these as far as I see if any questions for you guys. I do have some of you guys coming back in. Sophia, Ryan, Shalani. All right, so we'll go ahead and come back to those in a second, but let's go ahead and finish off the multiple choice, and then what I'll do is I'll go ahead and answer some of the questions that were submitted previously, and then if whatever time I have left, guys, I will go ahead and try to answer those on the stream as well. Perfect. All right, so the first one says, give the vertices of the following hyperbola. All right, so we know the center is at 0, 0, and we know a squared is equal to 16, so a is equal to 4. We see that a squared is under the x, so we know it's going to be a transverse axis that is left and right. So again, do not make the mistake that of 36 being your a squared because it's larger than the 16. That is for when it's a plus and it's an ellipse. In this case, your a squared is going to be 16 because that's your positive, or as listed first. And since a squared is under x, it's going to be going left to right. So from the center from the center 0, 0, that'd be left 4, right 4. The next one says find the vertices and the asymptotes of the hyperbola. So again, guys, what we want to do is set this equal to 1. So we're going to divide everything by 144. When dividing this by 144, 9 times 16 is 144, by the way. So you get y squared over 16 minus x squared over 9 equals 1. Okay, so now our a squared is equal to 16, which is under the y. So now I'm going to be going up and down from my center 0, 0. So therefore, it's not going to be this one, not going to be that one. Now we just got to remember what is the equation for the asymptote when it has a vertical. And that's going to be y equals plus or minus a over b. So since a is going to be 4, I know that needs to be in the numerator, so then my answer is a. All right, next one. this one is basically saying write the equation of the hyperbola. So we're given the center, the focus, and the vertex. Now this one's kind of interesting because they don't give you the plural. Like we know hyperbola has, a foci, has two foci, right, on either side of the center, as well as two vertices. You have on either side of the center. So this one's only giving us one, which is fine. We just know that it's going to have that reflexive property, like it's going to be symmetrical. So let's go ahead and sketch this to determine, is our transverse axis horizontal or is it vertical? So we have 1, 2, 3, 1, 2, 3, 4. So that's my center. My focus is at 6. 1, 2, 3, 4, 5, 6. 4. And then my vertex is at 5, 4. Okay, so obviously, guys, if we were to submit these like over, we would know that it'd be something over here, right? Now, we actually don't need to graph these at all because from this point, we can determine our values of A and B. So, or I'm sorry, A and C. So A, in this case, is going to be 4, and our B, in this case, is going to be 5. No, that's our C is equal to 5, right? The distance from the center to the foci is C. So C is equal to 5. Now, we can see that our center is at 1, negative 4. So that's going to be x minus 1, y plus 4, which is all of them. We said a squared is going to be under the x, so that's going to be important. So we know that one doesn't work. All the rest of them do work. And then, it should be an x minus 1, right? Yeah, so that one doesn't work. All right, a squared 16, and we know c squared is not going to be 25, right? Or b squared is not 25 because c squared is 25. Let's just go ahead and figure it out, but I know the answer is going to be c, but let's just go ahead and figure out. Remember, it's a squared plus b squared equals c squared, so this is 16 plus b squared equals 25, so b squared is equal to 9. So therefore, you can see obviously your b squared answer is A. All right, last but not least, guys, is we have convert the equation to standard form for the hyperbola by completing the square on x and y. So here's another completing the square problem. So in this one, a little bit more in depth than the last problem we need to do. So let's go ahead and group the x's and the y's. So we're going to do x squared plus 6x minus y squared minus 4y, and then equals a negative 4. So I'm just going to group my x's and group my y's. Now, the problem with grouping your x's and your y's right now is there's not really a good way to group with a negative. So what we're going to want to do is actually group this as an addition problem. So I'm going to change this to a negative y squared minus 4y equals negative 4. So by changing this to an addition problem like this, now what's going to happen is I'm going to factor out this negative. So you might be looking at me like, why are you going through all of this work just to factor that out? Well, again, remember when you're completing the square, you can only have your A for each of your, quadratics needs to be 1. So this negative doesn't work. Now, again, when you distribute that negative back through, are you going to get back this original problem? Yes. But now you can go ahead and complete the square because previously you couldn't group completing the square with that negative, so you had to factor that out. All right, so now we need to take our b divided by 2 and square it. So I'm just going to have to do my work over here. So I'm going to take 6 divided by 2 and square it, which equals 9. And this one I'm going to take 4 divided by 2 and square it, which equals 4. So therefore I have an x squared plus 6x plus 9 minus a y squared plus 4y plus 4 divided by 2 is 4, 4 squared, no, it's 4, what am I doing? It's 4 equals, now what did we add here? We added a 9, so that means I need to add a 9 over here. And then here I added a 4, so I need to add a 4 over here, but then also, don't forget, you didn't really add a 4, you added 4 that was multiplied by a negative 1. Okay, so now we can rewrite this binomial squared. So this is going to be x plus 3 squared, which automatically I can reduce those. This becomes a y plus 2 squared. All right, we got those two. And then this one is y plus 2. Oh, obviously it's going to be minus, but and then I equals 1, and you can obviously see that this is, again, a hyperbola, so that one will make sense. So you can see my answer is going to be B. So there you go, ladies and gentlemen. That is some multiple choice questions in there. And I apologize, guys. I kind of got a little late to my live stream, so I didn't actually write down the questions and where they're from. So I'm just going to go and pull those from the Facebook here real quick. I did at least get that to you. Ivan, thank you very much for giving some. Ivan, if you go ahead and join on my thing, I'm sure there'll be people on my Facebook page that answered some questions. That obviously, feel free, guys. As far as on my Facebook, whenever somebody posts a comment and on a question, I'm not going to be able to get to everybody's eventually there. So whenever you guys are able to, help each other out or answer some questions on there, will be greatly appreciated from there. I got Dahlia brought in some questions here at the last minute. Wasn't able to see that before I went live, so I'll try to see all those. Come on. All right. Come on. Okay, so one question by Laura Orozco says, let's go ahead and do this one. We have 3x plus 1 raised to the 1/4 plus 7 equals 9. And then there was one more. No submitted. And I guess next time I'll just have to make sure that I have enough time to go ahead and look at those. Or I looked at some of them, but I wasn't able to get to the other question that I had. Where'd that go? Thought I had another one. All right, I guess I'm not. Oh, there we go. It's probably dug in there down below. So let me try to read in there. Nope, not going to see it. So, all right, perfect. Let's go and see what Dahlia posted for solving logarithmic equations. I'm not sure what you're trying to do, so I'm going to have to work on that. So, Kyle, hey, how you doing, Kyle? Gitan, how you guys doing? Redstone, Albert Test, yo, thanks for saving my math grade. You are very welcome. 6570, awesome on inequalities. Good for you. MathBot loves things. And Matt's awesome. Velvet's okay. All right, so let's go ahead and take a look at this one. I'll go ahead and try to see if I can figure out where that other question came from. I know I had it. I'm not sure why it's not popping up, though. Daria, you might have to let me know what exactly you're looking to doing. If that's condensing, I'm assuming that's something that you're looking into doing. Oops. There you go. But I'm not sure what exactly the question that you are actually wanting me to address for that. So just make sure when you guys are go ahead and go into the Facebook and posting a picture, just make sure you guys are trying to be as clear as you can. So therefore I can understand exactly what it is that I am trying to look at. So therefore I can either tell you what exactly that you're going to want to look for or to do, or therefore I can or therefore I at least know, like when I'm writing it down, what exactly I'm going to be looking for in that. That's so weird. Maybe. What was that other question here that we had? That was in thing. So Aldo asked, so how would you rewrite cosine squared of 4x? I'm not sure how. What do you mean by how to rewrite that? So go there. Just trying to see if there's any more questions any of you guys have. Good night, teach to them. Nope. All right. Well, I'm just gonna have to work with this one. I'm sorry, I lost a question, but I'll have to go ahead and find it. And when I do, I will just personally respond back to whoever left the comment. I'm sorry, I missed that. So let me just go and work on this. I'm kind of past my time anyway. So let's go ahead and work for this one. So, just remember a couple things with when we have rational powers. Remember, guys, that's really just the same thing as the, fourth root of 3x plus 1 plus 7 equals 9. Now, a lot of times, usually working with the rational power is going to be preferred than dealing with the root. But, I mean, the same kind of thing is, the same idea is even if you're dealing with the square root or the fourth root, we want to isolate the root. We want to make sure that to undo the fourth root, we're going to need to raise it to the fourth power, just like a square root, right? So we can do that as rational powers, or we can do it as radicals. But before we can do that, we got to isolate this quantity. So to do that, I'm just going to subtract. Let's do this in red here. So the first thing I'm going to do, I'm going to subtract that by 7 on both sides. By doing that, I have 3x plus 1 raised to the 1/4 is equal to 2. All right, now, to undo something to the fourth power, we could basically raise this power. Let's say you can do it this way, 3x plus 1 equals 2. So now we could raise this to the fourth power, right? And you could do it this way too. But again, whatever you're going to do to one side, you have to do it to the other side. So if you took to raise this to the fourth power on the left side, now we have to follow the rules of radicals. The rules of exponents. And remember, when you have a power raised to another power, you're multiplying them. So that's going to give you a 3x plus 1. 2 multiplied by itself 4 times is going to equal 16. Here, you can just think about the inverse operations of the fourth root of something to the fourth power. There's supposed to be a 1 there. Is just going to leave you with 3x plus 1 is equal to 16. So either way, now you can go ahead and subtract the 1 from both sides, and you get 3x is equal to 15. So x is equal to 5. So there you go. Hopefully that kind of helps you, again, just looking into right about this. So Diego has a question. Say we have a point on the curve of a circle. If we reflect it over another point on the circle, would it pass through the center? And yes, Diego, if you're looking at look at the definition of a circle. So here we have a center. All right. Now the definition of a circle is a set of points that are equidistant from this center. So they all have the same length. Now my circle is horribly drawn here, but my point that I'm trying to bring to you is that all of these lengths are all the same, right? So let's pretend this is all 5, right? These are all 5 lengths. The distance from the center to all of these points is 5. Now, obviously my graph is not bad and I shouldn't be going past here, but the distance from the center to there is 5 units. So whenever there's a point here, if it's 5 units away, then over there it can be reflected over to be another 5 units away. So yes, that reflective property that I believe you're looking for is going to be a part of the circle. You can see there's infinite many lines. So another way maybe to represent that, if you have your reflexive property, that means you're going to have lines of symmetry. Well, since every single point is 5 units away here, you're going to have infinite many lines of symmetry, right? Whatever point is here, you can reflect over there. And a circle has infinite many, whereas a rectangle doesn't have infinite many lines of symmetry, right? You have this line of symmetry. You have this line of symmetry, right? But this red line is not a line of symmetry, right? This point is not back over there, is not on the rectangle. So you have that reflexive property with the circle for all the points, infinite many points. The difference is, same thing like when we're dealing with an ellipse, yeah, these points are reflective, right? These points are reflective. So your vertices and your foci, have that reflection about the horizontal and your vertical major axis. And so your circle is going to have that as well. The circle actually goes even farther than that and says all points on the circle actually have a reflective property. So hopefully that answers your question. Fellows channel, everyone was looking for a question I can upon the answer to the original question. Thanks, Ivan, because it's a vector, only can cross multiply with other vectors. Oh, would this reflector work if the circle was cut in half, though? Well, no, it wouldn't. So, if you took a circle and you cut it in half, then you'd have a half of a circle. Now, obviously, then, as far as drawing lines of symmetry, this point and this point are reflective about that line of symmetry, but this is the only line of symmetry, and these are the only points. So I guess apart that line of symmetry, they would have that reflective property, but that's the only line of symmetry. So by cutting a circle, now you only have one line of symmetry, but when you had a circle, you had infinite many lines of symmetry. So I'm not sure what the point that you're trying to get to, or at least on your problem. But yeah, by cutting your circle in half, now you have reduced to one line of symmetry from infinite many. I really want to see if I can find that question. Now it's bothering me that I don't have that question. It was like a quadratic dividing by variables, and I can't remember who sent it. So if you are in the chat and you're able to rewrite it, I would love that. But either way, I know I'll go ahead and find it, and I'll go ahead and send it to you. So either way, guys, I'm going to go ahead and take a look one more time, but just want to take you guys a reminder that we are going to do a quiz in this class. So I will let you guys know, but at least for my other, so here's the thing actually I think I forgot to mention. So when I'm going to try doing my quiz, my school stuff, I'm going to try to do that a little bit quicker because it is time intensive and we've already been going live for an hour. So I am not going to be posting those as far as for questions. I'm just going to basically go live, get my students, go over it, not really spend time answering questions online, because then what I'd like to do is reserve this time frame for the Mondays to really, let you guys know ahead of time so you guys can post your questions, because it's kind of difficult, when I was doing my school stuff to always let you know when I'm going to be going live, and then I have to send out the emails and do all that kind of stuff, and it was pretty time intensive. And then plus with school and everything else, it was very hard to know when I was going to go live. So what I was thinking of was well, you know what? Why don't I do the stuff for my students that I need to do? Basically going live, answering their questions, helping them out. And then what I'll do is I'll just make sure I have this time, this Monday, reserved for you guys, so I can basically answer your questions, have you submit questions, and go through them in there. So therefore, I can do my school stuff a little bit quicker, not spend as much time, but still go live with them. And then for you guys, I can spend a little bit more time and actually get your questions for you. So this is going to be my last live stream where I'm going to mix in homework for my classes as well as open Q&A. From now on, I'm going to do just an open Q&A for you guys, and then I'm going to do live streams for my students. So they're going to be about the same time, but rather than trying to do Q&As with that, I'm just going to try to get those separated. So just wanted to kind of let you guys know how I'm plan on kind of changing that up. So let's see. Try this one more time. Come on. I should have written them down. That's what I should have done. And then I would have had your answer already ready to go. But I do apologize for that. Oh, so that's why most relevant. It's still not showing up. Okay. I am sorry about that to the person. So I'll go ahead and take a look at those, and I will individually get with you guys. For the rest of you, how do you convert from a radical to a decimal? Mustafa, you got the question just when I was trying to sign off. My best guess for you is my best guess for you is just to estimate. Like square root of 4 is 2, square root of 9 is 3, right? Square root of 16 is 4. So when you have numbers like, for instance, square root of 5, that's between 2 and 3. When you have the square root of 10, like that's some decimal between 3 and 4. Obviously, you can get a little bit more detailed into actually converting that decimal, but that's never something I've really had to spend my time with, because basically just usually for most operations, just having an estimate has been good enough. So that's where I've kind of stayed with that. And Eliza, I see your question. Unfortunately, though, I do have to sign off. So I'm unfortunately just a little bit at the very, very end for me. But please, I will make sure that please make sure you check in for next week if you have some more questions, and get that into me beforehand, and I'll be more than happy to answer it. Chase Cano, again, you get the questions right. See, that's the problem. I get the questions right at the end when I'm all done, and then it's like these live streams can just like get run. So just make sure you guys go on and with my Facebook, get those submitted or on my email or on my YouTube memberships, and then you guys can go and get that stuff in there. Tom asked, anybody ask the question or on your FB site, or is it just members? My Facebook site, my Facebook membership is completely open for everybody. So I did do a couple groups where I was trying to like organize some things, and I'm probably going to close down those groups and then maybe reopen them. But as of right now, I'm just going to take the questions, as open, and that's something I'd like to do. Obviously, I think as this can grow, then, as far as like my YouTube members and everything else, that's something I'm looking into doing, like some private live streams just for them. So a little bit more of a smaller setting, because obviously if people get a lot of questions, these live streams can take forever, and I'm never going to get to people's questions. So YouTube membership is one way that I'm looking into, slower or breaking down that segment even further to give people a little bit more individualized help. And as of right now, their questions I check first to make sure I can get those addressed for them before I get to my Facebook page and so on and so forth. But as of right now, we're just going to keep on building up the questions, and then we'll just kind of see how it goes. But right now, anybody can, post a question. And that's what I'd kind of like to do, is just keep on getting some questions here for you guys that to help you guys with your math even on the Monday. Again, all the questions. Arson doing homework. Good for you, Arson. Proud of you, buddy. All right. Yes, Chase, definitely going to go ahead and probably go to Mathway would probably be a good idea. Go to Mathway, check your answer. But you're going to want to make sure you set your quadratic equal to 0, and then you can go and factor. But otherwise, guys, feel free to keep the conversation going on. But I am going to sign off. All right, guys, have a good night. Cheers.